Good morning, students. As you know that we have completed our chapter number 1 in chemistry, that is matter in our surroundings. So today we are going to discuss some NCERT questions. Liquids generally have lower density as compared to solids, but ice floats on water. What is the reason? Though ice is solid, it has a large amount of space between its molecules. And these spaces are larger as compared to the space in the water molecules. Thus, the volume of ice is more than water, and so its density becomes less, and when the density is low, then it will start floating on the surface of water. That is why ice floats on water. Desert cooler works better on a hot and dry day. Hot means temperature is high. Dry means humidity is low. So if you recall the factors which are affecting the rate of evaporation, then temperature is proportional to the process of evaporation. That is, more the temperature, more will be the process of evaporation. And humidity is inversely proportional to the process of evaporation. More humidity means less will be the evaporation. Now, according to this statement, the condition is that the day is hot and it is dry. Hot means, once again, temperature is high, and dry means the humidity is low. So what will happen? These two factors, that is the high temperature and low humidity, then the process of evaporation will increase. That is why the desert cooler works better on a hot and dry day. With the help of this picture, we can recall how the desert cooler works. That is, the hot air from outside is sucked by the pads, and on that pads the water keeps on dripping, and in the front of the cooler there remains an exhaust fan. Now what happens? Because the water works as a good coolant, so it will absorb all the heat from the outside air that is hot, and the cool air will be sent inside the room. Next, give reason for the following. Naphthalene balls disappear with time without leaving any solid. Naphthalene balls, you must have seen your mother putting the naphthalene balls in the warm clothes when they are not in use, and if you will open the clothes after some time, that is after a month or the two, you won't be able to get anything over there. No substance will be left, and you won't be getting even the naphthalene ball. They will disappear. What is the reason? Let us recall that when the substance change the state, then sometimes under the particular conditions, what happens? The solid converts directly into the vapors without leaving any residue. That is, the no substance is left. Solid converts into the vapor directly. And one of the examples of our everyday life, that is naphthalene balls. So naphthalene sublimes and it changes into the vapor completely, and so no solid material is left. Next is, we can get the smell of perfume sitting several meters away from it. Recall the process of diffusion, that is intermixing of particles of the different states of matter into each other on their own. And this diffusion process occurs more when the substance remains in the gaseous state, because in the gaseous state the particles will have more energy, they will keep on moving at a faster rate. So this is what happens, that perfume contains the volatile solvent. Volatile means the substance which convert from the liquid to the vapor state. And the particles of these solvent, they diffuses quite fast and can reach to the people sitting several meters away. Next is, why is ice at 273 Kelvin more effective in cooling than water at the same temperature? That is, if anybody will get the burn, then immediately what we do, the first thing, we take some ice piece and rub it on that part of the skin. It is due to the fact that the removal of heat from a system results in cooling. And ice takes latent heat from the surrounding to convert into water at 273 Kelvin and then into water at a higher temperature. Thus, in case of ice at 273 Kelvin, there will be a change in the physical state, whereas in case of the water, there will be no change in the state. Hence, lesser energy will be taken from the surrounding, but it is not in the case of ice, so ice produces more cooling effect than water at the same temperature. For any substance, why does the temperature remain constant during the change of state? The temperature remains constant during the change of state is because the heat supplied during the change is used in overcoming the intermolecular force of attraction between the particles of that state and not to increase the temperature. One of the examples from your everyday life is when you are cooking some food in a pressure cooker, and once the steam has been formed inside the cooker and you get the first whistle, so better is you put the knob of your stove, gas stove, on a lower level, because the steam which has been already produced inside the pressure cooker will be able to cook the food, because it has been already the heat which we are providing from the gas has been already used up to overcome the force of attraction between the particles of the system, that is the food inside the cooker. So it will not increase the heat, it will not increase the temperature, but it will increase only the space between the particles, and the vapors are formed. That is why you will be getting the whistle again and again when you are cooking the food in the pressure cooker. Next, the water kept in the earthen pot, that is matka, becomes cool during summertime. Matka means made up of mud. That is what we prefer to make our water cool in summer. Mud that remains porous. So when the matka is prepared, so its body will be having the pores. And when you fill the water inside the matka, then some water droplets will keep on pouring out from the pores of the earthen pot. And because the outside temperature is high, so what will happen? The water from the surface of the matka will keep on evaporating. And for this evaporation, it has to take the energy. Now, obviously, from where it will take the energy? It will take the energy from the water inside the matka, and that will result in the lower temperature of the water, making the water cool inside it. So with this, we have completed the chapter. Now in the next class, I will give you an assignment that will be evaluated. So be prepared for it. Good luck.